What's going on, digital wildcatters? It's been a while since I've done a podcast. I botched my intro. I never botched my intro, but got a packed house today with Perceptive Sensor Technologies. We've got Earl, Jim, and Jim. And so they made it really easy for me on the names. I love when I have multiple names.
We're considering having Earl change his name to Jim also.
Yeah, so we got to have Jim cubed here. So guys, really excited to have y'all here. We've got some equipment in the house. I love when we have shows where we have some equipment so we can show it off on camera. But real quick, before we get into the show, who wants to take the lead on giving me the 2-minute pitch on what Perceptive is?
I can do it.
Cool.
Perceptive Sensors, we produce sensors that can analyze liquids in real time. So we do that from the exterior using NDT technology. We can look into a pipe or a tank and we can tell you it's 87 octane, it's diesel number 2, or it could be a combination of those two. And that's where we develop one product from that right now. We have another one in the hopper that probably comes out at the year end. That's more around the tank sort of field. Technology was founded in a barber shop in Tucson, Arizona. And we developed it from the military and from looking for chemical weapons in Russia.
Cool. Yeah, I heard the other Jim talking about that here. So we're gonna dive into that. And Jim, you're telling me that you're in town for a conference. Are all of y'all in town, or some of y'all in Houston? I know I talked to Earl over here. He's Cajun, so I know where he's from. But what about you guys?
Yeah, I'm from Tucson, Arizona. That's where the company's based. And as Jim said, the technology actually came out of the Defense Department, chemical weapons detection, that sort of thing. And eventually drug enforcement got involved with it. And in Arizona, we have a lot of drug issues that come across the border.
Yeah.
And we found out about the technology, went and tied it up, brought it out and showed it to people in the oil and gas industry in Texas, and they gave us a thumbs up. So we went back and tied up the exclusive rights to 5 patents from the U.S. government. We filed 80 cents, been awarded to over 25 on different applications. The technology is really foundational. You can do a lot of things with real-time fluid identification.
Yeah.
And the important thing that Jim mentioned, it's non-invasive. We don't have to cut a hole in a pipe or anything. We just mount on the outside.
Yeah. So let's peel this back a little bit and talk about, before we get into the application in oil and gas, I want to talk about how this was invented as a chemical detection weapon in the military. And you brought over this Pelican box over here. So will you pass that down the table real quick? I want to have this, take a look at it as you're telling the story. But there we go.
This is a portable, it's a portable unit.
So I'm going to show this on camera. All right, there we are. So you can see we have this portable computer here with what I'm assuming is a scanner. So it's like I'm about to check out some groceries at H-E-B here.
More of a wand. More of a wand. It has to be against something firm, and then you could actually find out what's in there.
Okay, yeah. So you're pressing this up against any tank or steel. Does it have to be metal?
No,
because you said they're using it in drug enforcement.
Yeah, glass, plastic.
Okay.
Yeah, all sorts of things. And actually, that's what the FBI really wanted to use it for, was for security. So
interesting. So tell me, I think I heard you telling John earlier before I got on the podcast about how this was used. Was it the Cold War when it was invented?
We signed a treaty with Russia that gave us inspection rights on chemical weapons. And the primary delivery mechanism for chemical weapons is artillery shells. And so we had the authorization under this treaty to be able to go to Russia, to go to their armories, where they'd have tens of thousands of artillery shells and inspect them. But how do you inspect an artillery shell without cutting it open to find out what the chemical agent is? And so the State Department went out to many of their national labs, and the one that's most prevalent and active in chemical and biological and nuclear is the Pacific Northwest National Labs. They've got about 4,400 scientists and research associates up in the state of Washington.
Yeah.
And they were able to distinguish the different chemical agents, whether it's sarin gas, mustard, whatever else. And then subsequent to that event, they were high-fiving each other. They did that and were happy to do that, the results. The FBI heard about it, put more money in it with the idea that they could use it for detection of drugs, precursors to build drugs, that sort of things for drug interdiction.
Yeah.
And for a variety of reasons, it stopped development, and it was sitting basically in a closet up in the state of Washington, and we found out about it through retired drug enforcement people that were in southern Arizona.
Getting a haircut.
It was through a barber shop.
Is that what happened? Tell me this story.
Literally.
Yeah.
So
there's a,
in a barbershop getting a haircut and you just kind of hear it, pillow talk or
one
what?
of our other team members knows the barber. So, you give all your secrets to the bartender or whatever. In this town, you tell your barber, what's going on. And Billy found out about it. Billy Coleman. He was partners with Jim in a couple other things. Jim had some business over here before, renewable diesel, and he sort of knew the business. And they sort of said, well, this, oil and gas business, people end up stealing it. It's adulterated. There's other things that happen with fluids. So maybe we could be value added with this instrumentation.
Yeah, that's it's pretty fascinating. I think that there's, if you look at deep technologies that are invented, there's tribal knowledge loss where, hey, someone might have been aware of a technology and then that generation passes away and we lose knowledge. But then you have deep technology that just kind of sits in these silos. I was talking to someone the other day at Phillips 66 and they're telling me the story of this protocol. Is it the MQ protocol? I don't know, you guys are IoT guys, y'all probably know better than me. But anyways, Phillips 66 invented this protocol for pipeline monitoring. And anyways, long story short, this protocol is widely used now, and like even Facebook uses it to build Facebook Messenger off of. But for years, people within that company had no idea that this technology even existed. And so I think it's pretty, it kind of shows the opportunity that's out there that these technologies exist in these silos. And it's really about, hey, where can we find a commercial application for these?
Yeah.
And it might just be one conversation in a barbershop away from discovering it.
And I think this is time for me to jump in with my story.
Yeah.
So these guys, Jim and Jim, decide, they had some preliminary talks with folks. They decide to go to a trade show. So they go to a trade show in Florida that's mostly about storage tanks.
Okay.
And I've been speaking at this trade show and involved for years. And so, as Jim likes to say, I always go to the back corner because they put the new guys in the back. The people that pay the big bucks are sitting up front.
Yeah.
So I wander in the back and I see the worst trade show booth I've ever seen.
Whoa.
So it's these two guys, the box with the gun looking thing.
Yeah.
And like 3 paint cans. And I said, hey, what are you going to do? And they say, oh, we can tell you this one's got water in it. This one's got diesel. This one's got diesel and water. And I'm like, that's cool and everything, but I don't really have a lot of unlabeled paint cans, lying around. But we talked and I thought, So then I said, hey, what about the very top? I said, there's nothing there. And I said, could you tell me that? And they were like, go away. I went, no, seriously, could you tell me? And they talked and they said, yeah. And I said, I would buy that from you. And I was working at Kinder Morgan at the time.
Okay.
Very large,
Yeah.
And I had a need for it. Let's just put that. And I had some young engineers with me. So I said, hey, go over there and see if you see the same thing I see. And then we got to talking, and as Jim likes to say, they didn't know who Kinder Morgan was.
Yeah.
They thought it was
Software guys.
They thought it was Captain Morgan. They were like, yes, we're getting into,
I love rum.
We thought we'd hit the gold mine.
And so, so we worked together, and, to be honest, so I gave them a laundry list of things that if you can do this, come see me, thinking I'd never hear from these guys again.
Yeah.
And a few months later, they show up at my office downtown and said, hey, we can do all that stuff. And I went, really? Anyway, so then we started prototyping things. And
Very cool. When was this? What year?
This is 18, 19, probably
18.
19 at this
It was
point.
18.
Okay, cool. Yeah.
So,
So Earl threw us to the Wolves. So we saw him in a nice, friendly manner. And then we went out to a Kinder facility because he was a little bit under the radar at this point. And he wanted a reality check. So he pulled in one of the older Kinder person.
Mm-hmm.
And we set up we got a pipe and we stood it up on side. So we just said we had paint cans. We can actually prove it out more of a prototype going through a large piece of steel. So we did that. We put diesel in there. We proved that. And the guy said, oh, okay. And he was the man of very few words.
He ran the labs, right? The test labs.
Yeah.
Yep.
Leo ran
Leo, all right.
Leo's the guy that worked his way up, 30 years from an operator, and he was running all the quality labs
Yeah.
at the largest liquid terminal complex in North America.
Yeah.
So it's a big deal.
Yeah.
So
So
keep going.
we have the 3 paint cans again. We do a little dog and pony show. And it's a room very much like this. And Earl deserts us. He goes and sits way back in the room. So it's Leo, there's Billy, myself, and Jim. And we're having this conversation. He's like, okay, so here's water, here's vinegar. We don't always, walk around with it like flammable liquids. Here's whatever. He's like, He sort of gave us a nod. And then he reaches down for a milk caddy of petroleum bottles, and he slams it on the table. He's like, okay, let's do this. I'm like, wait a minute, they're glass. We just have to recalibrate. So he looks at one. He's like, try that one. So Billy gets up. That's 87 octane. And he doesn't say anything. Try this one. That's number 2 diesel. Okay, that's heating oil. So boom, boom, boom. We hit them all. And then like number 5 or 6, Billy's like, I think it's a premium, but I can't really tell if it's a premium. He's like, yeah, I threw you a little curveball there. It had an additive in it, but you actually got it.
That's awesome.
So with that, I looked at Earl. He's like, just walk out. Just put your head down and keep your eyes down to the ground and walk out. And Leo was just sort of shaking his head. He couldn't believe what we did. So
yeah. So Earl, pass me the sensor real quick.
Yeah. There you go.
So let me show everyone on camera what this thing looks like. So one, tell me what I'm holding here, and then I want to talk about how the technology works. You know, I'm super curious, like how does it differentiate between fluids?
That is an early version that's you know that has been put out in the field. But if you look, so you see the curved piece.
Yeah.
So that would fit on. Imagine that's fit on some top of a piece of pipe.
Okay.
Okay. And then the box that you're holding has the brains in it essentially.
Yeah. Okay.
And then the top there, you can put an antenna so you can send a cellular signal off.
Gotcha.
And what it does, that sensor, the little black thing on the back side.
Yeah.
Right here.
That's the sensor. That sends an ultrasonic pulse through the steel.
Okay.
And just like with a handheld, essentially you have to know how thick the steel is, and you send the pulse through and you kind of ignore that piece.
Yeah.
And then there's a number of metrics. This is kind of our secret sauce, but there's a number of metrics we can use that helps identify the different liquids.
Gotcha.
So 87 octane looks different than number 2 diesel. Jack Daniels looks different than Gentleman Jack.
And that our guys figured
So
that
it's
out
not
one Friday
really
afternoon. They were
interesting.
bored.
Yeah, so it's not just oil and gas. It's all kind. We've got a project right now where they de-ice planes. These thing called PEG, polyethylene glycol. We can tell, and what we found out through testing, which we didn't know to begin with, was if you have 2 liquids that you put them together that they don't chemically react, we can tell you how much of. If we know what we're looking for, we can tell you how much of each.
Oh, you can tell the makeup of each. Yeah.
Yeah. So like polyethylene, like on the airport, they when they start it's 100%. Well, then after it de-ices and it's less than 100%, but if there's a point where if there's still, I don't know the number, but there's some number, 20%, whatever, they can still use it again.
Yeah.
At some point it's too diluted and they want to dump it down the drain.
Yeah.
But we can tell them that it. So,
Interesting.
And in the oil and gas world,
I was going to say, let me stop you
Go
real
ahead.
quick, because it's kind of fascinating, like the whiskey analogy, because it'd be impressive, like, oh, it can tell the difference between whiskey and water and Coke, but you're like, no, it can actually tell the difference between different types of whiskey as well, which is
watered down whiskey. Maybe somebody at 12 o'clock will fill it up again, and we could.
What you're hitting on is exactly when the Pacific Northwest Labs was doing the work for the military and the FBI. They had an epiphany moment it's proven out to be exactly true. Every liquid has a unique acoustic fingerprint. And as Earl said, you have multiple metrics, acoustic metrics, everything's temperature compensated. So the magic that Earl referred to is knowing what metrics to use, making sure we have the temperature compensation model set in. For us to add a liquid to our database, we have to run it through the range of operating temperatures we see it at.
Yeah.
And it creates curves, and it's extremely, extremely accurate.
Yeah, so that's what I was going to say, is that you guys have to go create this database with all of these inputs of, hey, this is the acoustic profile of, this liquid, and then you have to run it against different a spectrum of different temperatures and variables, and then you preload that into.
We've done Tito's. We've done a handful of non-petroleum products as well.
We've got a whole bar over here. Let's start, running tests.
Wait, this is Johnny Walker red instead of blue. Somebody ripped you off. But we have about 300 items in our database now, and we keep adding them every week or two. Somebody comes, like if you gave me your soda, whatever you're having, I would say, I don't know what it is, but we actually had a sample, put it in, and we can come back and say,
you'd have to pre-populate it and get the profile on it. Yeah.
In fact, before I joined, when I was still at Kinder, they came over to do a dog and pony show for some folks, and they had brought some diesel. They had diesel in Arizona that they calibrated on.
Yeah.
Well, you don't fly with diesel. So they came over here and bought some diesel.
Yeah.
And it didn't work.
And
they were like, oh, Oh, well, it's wrong. Well,
It was a private equity guy. He's like, thank you very much. Why don't you come back when this works again, Jim? I'm like, really? No, honest, trust me, it works. And I sort of knew this guy from my New York days.
The stories of your demos never working in front of investors it's a story everyone has.
But what happened, that you're learning, is that there's an additive they put in Houston for air that they don't put in Arizona. And our technology is so sensitive, it was picking up that delta. So it was close, but not.
Yeah.
And that just is like, oh, this stuff is really accurate. So we literally see if you have different, like 87 octane regular gasoline, a lot of people make it. We actually see differences in the different refiners.
Really?
So
that's interesting because like you always hear like, it's funny, like mechanics like to blame car issues on, it's bad gas, it's bad gas. And like, you never think like, it's like, it's just gas, gas is gas. But I'm sure that there's a huge quality component that goes into gasoline.
Well, as we said earlier, we're not from the founders of the company are not from the oil and gas industry. And we really listened to people like Earl who came back to us, and Kinder Morgan. They came up with 3 things they wanted us to do. One was the transmix as the materials going through the pipeline to differentiate so they can reduce the yield loss. Second thing they wanted was a tank alarm for the overfill and stuff like that. The third thing was actually working on loading racks at the trucks so they could verify and prove that what they put in the trucks going to the gas station was exactly what it's supposed to be. Because they don't want to have problems. People come back and say, I had an issue.
Yeah.
And the issue could have been the tank truck that pulled up may have had something in the tank that was not compatible.
Contaminated it. Yeah.
So
that's
they had
actually
no way
a
of
good point too,
defending
is
themselves.
like to prove your quality and have a record of that too, and do it in a scientific way where you have a ledger of, hey, this is what we sent you. And which I think that this is like really, not understood by even people in the industry, but outside of the industry is just there's so many different types of fuels and grades of oil and things of this nature. And I mean, it's super complex. And so being able to get insight into that is, that's a huge unlock.
So the top number one that Jim mentioned was we look at transmix. So maybe listeners don't understand what transmix is. So there might be.
I don't understand what transmix is. So tell me.
So it'd be finished product materials, right? So your gasolines, your diesels, things like that.
Yeah.
So they usually run on a pumping schedule, maybe from like in this area, there's Baytown and Exxon there. So for 2 days straight, they might push 87 octane. Behind that, they'll push number 2 diesel. So there's going to be some sort of commingling of those fluids in between. So I'm putting my hands up here. So they see this much, they see, 20 barrels, and they, just to be careful, they'll cut out 50 barrels. But we can see this in real time. We can see the transition from 100% of the gasoline going to 99, 98, 97, and watching the diesel coming from 1%, 2%, 3%, et cetera.
Oh, wow. So you can actually see it in real time processing as it's changing.
Right.
Awesome.
Right.
That's very cool. Yeah, I mean, it's already cool enough that you can differentiate, just putting it on there, but to be able to see it flowing by in real time is
and it's not
insightful.
just refined products. I mean, it's all kind of things, but we already talked about alcohols and things, but somebody sent us some blind tests of crude oils.
Yeah.
And we can actually see differences in the different grades of crude oils.
Yeah. Yeah.
So
that's what I was getting at earlier, is like you have different grades of oils.
52, 53, 50. I mean, we see a difference in it. It's not like 50 to, like a 50 API to 40. We can see like 50 versus 51 or 2. I mean, it's much closer.
Yeah. Yeah.
So
you can see a much more accurate discrepancy between them. And that brings me to my next question. Y'all are, obviously this has applications for all industries that use fluids, but in oil and gas, we've been talking heavily about downstream and refining, which makes perfect sense. Have you guys started taking this out into upstream applications as well for exploration and production companies?
You have to define, how are we taking it out? We do have somebody who's taken it and their imagination has run wild on them and good. And they've used it in the downstream, and we want to work with them more. So it's good application.
We've also, we have a project right now with produced water.
Yeah.
Which is an upstream application.
Yeah.
Because what happens, especially like West Texas, New Mexico, you get all this produced water. Well, they got to do something with it.
Mm-hmm.
You give it to companies that then take it, clean it up a little bit, and re-inject it. Well, there's specs on that.
Yeah.
And occasionally, like frequently, people will send them garbage or stuff they're not supposed to send them.
Yeah.
But since it's all commingled together, it's very difficult for them to decide.
Got lots of saltwater disposal bros that listen to this podcast, and so that's that's who I was thinking about.
I was in West Texas 2 summers ago to talk to somebody. Go ahead. One difference with the upstream, with that part of the upstream, is their tolerance for spending money is a little different than like the refiners or the actual drillers.
Yeah.
And so but we actually I have a project right now to go put 2 units out.
Nice.
In West Texas, New Mexico.
Yeah.
And they're just looking for like gross changes. We're not down to the parts per million. We're not telling you it's potable water. But like if somebody sends them a slug of garbage, we see that. Well, that's what they want to know, and how much oil too, because if there's a lot of oil, there's some oil in there, obviously. Yeah. But if there's a lot, then they want to divert that over the tank, let it settle out, and then sell it.
Yeah. Yeah. They want to pull that skim oil out. Yep. Yeah. Yeah. The water issue in West Texas, I mean, it's a huge issue, and actually have a deep belief that the future of water technology in the world will be solved out in West Texas, and then that knowledge and technology will be exported around the world. And you look at, I was talking to, I was in this roundtable meeting with a couple of VMP executives and the mayor of Midland and Senator Ted Cruz, and they were talking about all the oil field theft that's out there, and a lot of saltwater disposals are kind of part of that ecosystem, and so being able to track fluids is really top of mind for everyone. So yeah, there's just kind of all kinds of crazy applications. Now, when you're actually putting this thing, do the units come in one size? Like you said, you're deploying a couple units. Like, are these all are they custom to the application, or
they're custom to the diameter of the pipe for pipe applications? Yeah. And so for really small pipes, we need to use a curved sensor.
Yeah.
For larger pipes, we can use, I say large, like 12-inch on up. Typically, we can use a flat sensor because you get the curvature is not.
Got you.
Good.
Got you.
And
then this looks like it's 4.5 inches or so, and so.
And then for larger pipes, largest we've done so far is 36. We've actually, in larger sizes, we actually put 2 sensors on both sides of the pipe, so you're bouncing everything. Yeah, like that one is just going, it's bouncing to the other side and coming back. When it works, but you get more data if you have 2.
Got you. Yeah, yeah.
So
when you do small pipes, do you usually try to optimize to have 2 on each one, or you just say, hey, it's good enough with one?
It depends on the application.
Gotcha.
And it also depends on what people are looking for, because as we said, we have different metrics that we can look at, and some metrics for 2 different liquids are the same or very similar, but then that second metric is way different.
Gotcha.
If you start at, but some even at 2, it's kind of like if you want 87 and 87.5 octane gasoline.
Yeah,
those are pretty close together.
Yeah, yeah.
And we're not a GC, we're not doing, but if we start adding more, turning more of our metrics on, and it's one of the differences, and we had this discussion with everybody. We have units, and obviously there's a sensor there, but the magic is not that box that you're got in front of you. The magic is taking the data and figuring out what it means.
Yeah. Yeah.
So it's not like we're selling a widget per se. We're not selling a shovel to somebody.
Yeah.
It's call them analyzers or whatever, but it's kind of this weird middle ground there. It's not just a sensor. It's not just software. It's kind of a merging of the two.
Which I love. I mean, I love when you have the inception of software and hardware. So let's talk about that a little bit. What does it look like? Let's just say let's take a persona, someone in saltwater disposal is like, hey, this is really interesting. I want to deploy this. So they get their sensor on out there. Now what? Where is that data feeding to? Do you guys have a software platform that it feeds into? Or are you just giving a raw data dump to the operator? What's that look like?
Basically, the way we've set the units up is all of our units communicate back to, you can call it an edge server, or we call it a telemetry engine. Basically, it's a unit has 3 redundant servers in it, so it's high availability. If one goes out, you pop it in and out.
Yeah.
But basically, after we collect the data from the device in the field, this is like an intelligent data collection device. It goes back to the server. We do further analysis and come back and tell you this is number 2 diesel. Or if the applications just tell me if this product's on spec or not. We have people come back and say, look, we expect ethanol in this line all the time. If it's not, give us a warning.
Mm-hmm.
And so the eventual, vision, and Earl's been sharing with us, is terminals, facilities can have these units all over the place.
Yeah.
And so it's in every pipe going everywhere.
Yeah. You
And
essentially can map out an entire
major
facility
development
and see
for
it.
us would be a flow meter, acoustic flow meter that's really accurate. The
Yeah.
ones that are out there today aren't that accurate. We feel with all the information we're getting on the fluids, we can develop a very accurate flow meter. When you put a flow meter, accurate one, together with something that identifies the liquid, then you've got a digital manifest for custodial transfers, all sorts of applications.
Yeah.
But to your back to your question, typically what we do, because nobody believes us. I didn't believe these guys when and then, it's kind of like it's like there used to be this hair plug thing about, I'm not just a, investor. I'm a
user.
I'm a user. Yeah. So now I'm part of it. But so what we do is, and we can do it. And when I was still at Kinder, I told them, you need to be as agnostic as possible, because different people communicate. Some people love wireless, some don't, whatever.
Mm-hmm.
So we have we've built in a number of options. So for kind of proof of concept, we put it on there. We can even, that little hole on the end there is actually where we can put batteries on there.
Okay.
So that you don't have to run conduit and cable if you don't want to start.
Yeah.
And then we can do it wirelessly. We can literally do it with cell phones,
Mm-hmm.
so that you can see.
Yeah.
You can see it. We have an interface online in the cloud,
Gotcha.
whatever the cloud is. But you can actually see, if you have a unit on, you can see your data in real time.
Got you.
Which for most people is kind of like watching paint dry, because if it's just a line.
Not an
87
engineer,
octane.
so sit there and
But-
watch that.
But what we do, we're collecting all that data, and you can go backwards in time. So like you could, because one of the issues with the produced water is they say, during the day this stuff doesn't happen because they're taking samples, but there's nobody there at night,
Yeah.
and so or trucks are being offloaded at night,
Yeah.
but you can then go back and look and go, oh, well, okay, at 2:30 somebody slipped me a Mickey, and it's like, oh, Joe was the one that was here. I know who did it now.
Yeah.
And so that's where,
Yeah.
And then what I think for an operational purpose, most people are going to then take it, ultimately they're going to take our data and integrate it into their SCADA system or their DCS system or whatever.
Yeah.
But that's they got to be comfortable with it first, and
Yeah.
then they got to realize, oh yeah, this really works.
Yeah. Deploy it, see it working, and then once it works,
So
get it tied.
it could be a toss salad. I mean, all people have different needs. So we have one on a pipeline, which is just distillate. So you have jet going through there, heating oil, things like that.
Mm-hmm.
So it's very important for them to keep jet 100% clean. They don't want any of the fringes on the other, because you're 30,000 feet. You don't want diesel or kerosene going
Yeah.
into that.
Yeah.
So they want to make sure that's 100%.
Boeing
clean.
already has enough trouble.
Yeah,
going, they don't need more problems.
So in a case like that, they cut out, and they're supposed to cut out, 5 minutes of waste. They cut out 8 minutes of waste, or something like that. So
Yeah.
on this one pipeline, 1 minute is 21,000 gallons.
Yeah.
That's enough to fill a pool in your backyard.
Yeah.
So we can improve upon that for a minute. That's great.
Yeah.
And
Yeah,
the other
It's a good
pipe,
way to articulate the volume.
Yeah. Yep.
Yeah.
and the other pipeline is all gasoline. And, we have a certain amount of, things in our database, and things are going by, and we're like, Earl, what's that? And Earl's like, that's a subgrade octane. Like, okay, what's subgrade octane? Well, obviously it's something below 87. Like, we've never seen that. Where can we get that? Like, you're not going to get that. So we sort of found it. We put it in our database. So it was going through the pipeline. We analyzed it. We labeled it. It's gone there.
Yeah.
So in this pipeline,
So if you discover and this is just kind of a question of how y'all operate, like if you discovered something that was a subgrade octane fuel, now that you've seen it, are y'all able to go build a signature to that, so that the next time that you see it,
exactly.
you can identify it?
Exactly. Then we went back to the operator and said, was this subgrade? He said, yeah, that was subgrade. Was it between 1 o'clock and 4 o'clock? Yeah, it was. So
Okay.
we did that.
Yeah.
But this pipeline, when you push, there's a shoulder season. So in April, you have to transition from winter blends to summer blends. So all of a sudden, there could be 25 different gasolines in there. So
Yeah.
we were seeing a lot come by, and we've been analyzing and tagging a lot of things recently.
Yeah. No, it's pretty fascinating to think about the different applications for this. Really funny to hear the story of how it goes from Cold War technology to drug busing to hearing about it in a barber shop to now, getting people like Earl believing in it in oil and gas applications. For y'all, what other industries are y'all looking at applying this to outside of oil and gas?
Basically, chemical, food processing,
Yeah.
and logistics is probably the largest. If you take this technology and you integrate it in, say, an ISO container or a tote, and put GPS on it, you'd be able to tell at all times where something is, what it is it on spec, how much is there in volume, and how much it weighs.
Yeah.
Because once we know what the liquid is, if for instance, if you have a tote, like a 400-gallon tote, and you put our unit on there, you can identify the liquid. We know all the information about it, including its density and weight.
Yeah.
And with the second transducer on the bottom, so if we know the velocity of the acoustic waves going through it to 4 decimal places, we can get the fill label within 2 decimal places. At that point in time, we've got a volume. We know the material. We can give you the weight. So you could have a virtual manifest anywhere. This is, this heating oil or petroleum
cool.
or whatever.
I'm just thinking about like rail cars.
Think about in your warehouse, knowing what everything's out there that would do a physical count.
Does it make sense? Like I don't know how much these cost or what y'all's business model is, but like, on a rail car, I don't know how many rails you have on a typical car, but does it make sense to have like every single car outfitted with one of these?
Ultimately, yes. Today, I mean, we're still, we're a small startup. And one of the challenges we come up with all these. We were at an open house yesterday talking to another startup, and there's some synergies between the two. And we're sitting there with a PhD guy, and we're talking back and forth. I think we come up with 2 or 3 more patents, ideas. But the reality is, it takes time and money to do that. So
absolutely, you got to pick a path and go.
But we can, as Jim said, if we put this on the bottom, so like the big storage tanks, it doesn't make sense. But these horizontal tanks that are elevated, if we put our unit on the bottom, we can tell you precisely how much is in it and what it is.
Interesting.
There's other devices that can tell you that.
Yeah.
The other thing that is, as Jim's pointed out, we don't have to tap into the steel. And in our world of, we don't want any leaks or any potential sources or ESG stuff. So the fact that we're doing it all from the outside is a definite positive.
Yeah.
For a lot of people.
Real quick before we wrap this up, let me dive into that. He made a comment about if it's a horizontal tank and you can mount it on the bottom. I have a few friends that I was thinking about that are in downstream storage, and I have friends with chemical totes or oil tanks, and so can this be applied to tanks if they're vertical or no?
No, we can now. No, from a level standpoint, we can't get on the bottom of a big tank.
Yeah, exactly.
Tanks are kind of it's one of my things.
Earl sits on a few.
We got the tank guy here.
He sits on a few API. His nickname is the Tank Whisperer.
Okay. Earl the Tank Whisperer.
He has his business cards that say
I love
that.
it.
Oh yeah,
I love it.
But one of the original idea back with the worst trade show booth and the paint cans, my idea was for an alarm on a tank, because about every 3,500 times somebody around the world fills a tank, they put too much in it.
Yeah.
In fact, the state of Texas just passed a new law last year, SB 900, which now mandates more protection on 36,000 tanks in the state of Texas that weren't previously
covered
under it. And one of the things it does is references an API document, which I happen to sit on for 20 years. I'm the chairman of it at the moment. And so obviously you put an alarm on, you don't do it. So we have a tank alarm that you can literally, and we mount it with magnets. So there's no welding. It's wireless. It's battery. So you don't have to run conduit or cable.
Yeah.
Now, what kind of an off the shelf use, kind of like doctors prescribe stuff that's not on the, but our device, we've done this in the field, like a crude tank. If you hand move it, it's not practical, but if you hand move it, we can tell you where the solid bottom is. We can tell you where the sludge is. We can tell you where the water is. We can tell you where the oil is, because we get a different signal. And so the mad scientist, and I'm not the mad scientist. I know all the problems in the industry, but if we put a series of these on the side of a tank, we can get a level.
Gotcha.
And so that's kind of ultimately where I want to go, because then it's all from the outside.
Yeah.
You don't have to go to the top, open anything up, weld it, do anything.
Yeah.
And there's existing technology and devices that do that, but they break. And in a lot of facilities, the device itself is relatively cheap, but running power and conduit, that's expensive. I know of facilities that have hundreds of tanks that have nothing on them.
Yeah. Yeah.
And so
Yeah, just the infrastructure.
just the
to get
infrastructure
them.
alone
Yeah.
is
Yeah.
and we can be wireless.
Yeah.
So that's a big
Yeah.
that's a big plus for us potentially.
Got
So,
you. Well, this is super cool stuff, guys. Appreciate y'all coming in and showing it to us. If someone's listening to the show and they want to check y'all out, what's the website? Where can they find y'all?
You can find us on www.perceptivesensors.com or go into LinkedIn. You could probably find
Cool.
us there.
Find you guys there. Find
yeah.
y'all at the next local
And-
crawfish boil.
Yeah.
Bring
Yeah.
out some crawfish.
and I am here in Houston. If anybody wants to talk in person, I'm happy to show up and talk to them.
Cool, man. Awesome. Well, appreciate y'all coming in. If y'all enjoyed this show, make sure to share it with a friend. Leave us some comments, some reviews. Reach out to these guys, the great group of guys building some cool stuff, and we will catch you on the next show.